Good afternoon, everybody. Thank you for joining us today and taking the time out of your busy schedules to learn about the newest addition to the Senceive portfolio. Before we kick off, I'd just like to highlight the fact that we're running a simple poll in the sort of GoToWebinar section. It's a very simple question. It's just for us to understand what sector people are sort of looking at, where the product might be allocated to, might be useful for them. And so if you could take the time to just answer that very simple question, that would be supremely useful for us. Also, if there's any questions, please pop them in the form that's in the GoToWebinar part, and we'll answer them at the end, or try to anyway if I can. So for those who haven't met me, my name's Dom Quiche. I am the head of product management here at Senceive, and delighted to be introducing the digital interface node, which is a brand new product Senceive have brought to market over the last 6 weeks. So what I'd like to go through to today is a brief agenda here. I want to introduce you to the product range and why we developed this particular product and how it fits into our existing portfolio. Then go through the digital interface node more specifically. Look at some of the sensors that fit with the node. Look at those applications where you might use the node and where it fits into everyday scenarios. Then go through the way that InfraGuard interacts with the product, and finish up with a quick summary. So hopefully I won't take much more than half an hour of your time up today. And like I said, we'll rattle through some questions at the end. So what is it? It's part of our hardware range. We bring to market sensors, wireless hardware, wireless comms. That's where people have probably noticed our brands of FlatMesh and GeoWAN, and then software of Web Monitor and Senceive IO, which is some of you might not have heard of, but we're actually launching this week as a data management platform, and InfraGuard as well. As you know, I've sort of put it then as a software, but it sort of spans both software and wireless comms. And we aim to connect with market leading suppliers. We innovate where we see a gap in the market, but where we see sensors that open up applications and could be part of our communication network, we make sure that we can interface with them. So as I said, this particular product falls into our wireless hardware side of things. So it focuses on pulling the data from external sensors and third-party sensors, using our wireless communication networks, either FlatMesh or GeoWAN, passing it through our back end and either out to our front end or out to a third-party platform. And why digital? We have lots of interface nodes. Those of you that know our market and know our business and our portfolio, you'll recognize that we have lots of interface nodes already, things like vibrating wire sensors, potentiometric nodes, millivolt per volt nodes. So these are all nodes that can interface with sensors that have those type of outputs. And there are sensors in the market that really lend themselves to the digital output, which I'll talk about in a next slide's time. But it was very abundant, very clear to us that having a node that interfaced with digital output sensors is extremely useful. It's extremely viable for our key markets such as rail and mining. And so we wanted to go and make sure that we could meet a client's demands, meet a project's demands by having a node that can interface with those types of sensors. This is just a very sort of quick and short summary of the different types of output that you may come across, and you know, there's not a sort of definitive rule on why a lot of these are used in separate occasions, but especially when we look at the digital, one of the biggest outputs, one of the biggest advantages you can get from a digital output is the standard in defining the electrical characteristics of the drivers and the receivers could be used in the typical RS485, and it allows you to have balanced digital multi-point systems. So you can have things like Modbus and CAN bus and SDI12. These are all protocols that employ that same signal type of the RS485 output. And you know, the bottom line is the major advantage, sorry, of the digital, the RS485 analog system is that sensors can be bused, meaning that each sensor has its own individual address, and so therefore you can attach them to one cable, and when you get the output at the other end, you can actually allocate each sensor to each output that comes through, so you can minimize the number of cables that you have run on site. You can also have things that like you can do fairly long distances, but this is directly related to the cable and the voltage, and the longer the cable, the greater the signal attenuation and the power attenuation, so it's not infinite. And so when you start looking at the different outputs, you know, that you can get from different types of sensors, different ones have their different strengths, that's for sure. A vibrating wire has a very low signal degradation, which means you can do it over longer runs. Tolerates wet wiring, not that we'd ever suggest that that's a good idea, but millivolt per volt is very cheap to manufacture and understand. Potentiometric is very simple with a high level of accuracy. So every output has its advantages, and they also have their disadvantages. Digital has a very clear one in the sense that it can be bused and you can attach lots of sensors to that single point, as I sort of explained. And that's why we felt the need to add the digital to our portfolio. So it's not to overtake any of the other outputs, it's to diversify and mean that we can interface with another set of sensors for certain applications. So what is our digital interface node? It's the first of a new range of design that, aside from the obvious of having a digital output, it brings Senceive forward in their aim to keep the market requirements keep meeting the requirements for the market. The new enclosure is very lightweight. It's easy to exchange batteries. We have a simple 8-pole connector for the external sensor, so you don't need to do any wiring when you're on site. And again, another simple 3-pole connector for the external power should you want to use that. We also have the ability for the node to automatically switch between mains power or battery power. So it means that it opens up the possibility of attaching a solar panel directly to it if you wanted to. And it would mean that simply if the solar panel was not producing enough for the node to run, e.g. at night or in the winter, it would naturally flick onto its battery power. It means you've got a much more sustainable system for the long term if you were looking at some very long-term deployments. The whole node is NFC configurable, so it can be done with a simple app in the field if you want to, or it can be configured via our new data platform, management platform on Senceive IO. The node will also store data if it's not connected to the gateway. So if you've got a node that's not able to send its information to its GeoWAN or its FlatMesh gateway, it will store that data, and the amount it can store obviously depends on how many sensors are attached to it and what frequency you're sampling at. So in general, we, you know, as a sort of general stat, we put it will store about 6 months worth of data if you're sampling at 30 minutes of a standard sort of 20-meter IPI string, for example. You can set the node to sample from 1 second or right up to 1 minute. Sorry, 1 second sampling for a single sensor, or 1 minute sampling for say 10 nodes on sensors on a string. And one of the biggest advantages of the node is that it packs some fairly serious horsepower. We can output up to 20 watt range, and this is represented in the amount of sensors that we can actually attach to a single node, and the expected battery life that we see from the node. So there is a change going on in Senceive, and this, as I said, this is one of the first to the market for us of this new range of product, and it's effectively to make our kit more accessible to others, and mean that people can do battery changes and access the internals of the node should they wish to. And obviously we're going to set out guidelines of how that should be done, and done in a controlled manner. But overall, it makes it easier to change, to maintain the node, as well as shipping all over the world with the challenge of dangerous goods. We still use a specifically designed battery unit, and this enables us to get far more out of it and a much longer battery life. But we're not precious about those batteries. We can tell you where to get them from, and you can order direct if you so wish. We're not here to make money off of batteries. We're here to make everybody's life a little bit easier. And we have two types of battery, again, to make sure that we can cater for all kinds of conditions when the node is put into the field. So we have one that works at a low temperature, and can behave as we want it to, and one that works within a sort of standard temperature range. So I'm just going to sort of highlight some of the compatible sensors that we've launched the product with, and highlight some of the possible avenues, some of the possible sensors that you might look to want to integrate with a digital interface node. As I sort of highlighted earlier, when we look at the strengths of different outputs of sensors and why you might have them, one of the key strengths of a digital output sensor is its ability to be bus. So it's effectively the ability of a sensor to have many points within it recording information, and that to be transferred through a single cable. And the best example of that is probably an in-place inclinometer, where you've got multiple sensors going along a string, anywhere, typically between sort of 1 meter sensors or right up to 3 meter sensors, and going as far as sort of 150 meters deep. And in those cases, what you don't want is multiple cables coming out the top of a borehole or along a wall if you're doing a horizontal one. And you want a single bus cable. So it means that you can put that with the digital output, you can put that single cable directly into your digital interface node, and you can sample and read all of the sensors on that string. Also lends itself to geotechnical sensors like extensometers, when you're looking at changes in depth, and you've got, again, multiple sensors on a single string. Weather stations, where you've got lots of different sensors measuring different parameters such as wind, barometers, temperature, rainfall, and again, because of our sort of quite substantial horsepower, it opens up another area of sensors which require a large amount of power to get them going. Things like flow meters, and possibly things like accelerometers in the future. So today, at the moment, these are some of our partners that we've launched with, and we've done the integration with some of the major players across the globe, and enables us to be able to partner with them when the requirement comes along. And this is we're very open about who we partner with and how we can do things, and we want to extend this list and make sure that we are growing. And at the moment, it's very focused on IPIs and extensometers. But as I said, in the coming months, we'll probably have some news on weather stations and some of the other sort of sensors we had in the list previously. As with everything, with all things battery related, there isn't a one size fits all. But we have some pretty healthy numbers here on how what our battery of our system can achieve. This is, again, depends on what's plugged in. It depends on how many points within that, how many sensors within that string is plugged in, to how it may perform and how often you'll get readings out of it. So we've taken arbitrary 25-meter string. If sensors are every 1 meter, so you've got 25 sensors attached to one digital interface node, and they're sampling every hour. And I must stress that these numbers are at the moment very, very conservative. So we expect it actually to go a lot longer than this. So if we use a GeoSense IPI, we expect a minimum of 3 years. Same with GeoCon, a little less with SysGeo, and with the Osprey extensometer up to 9 years. And probably an even better example of the power that the sensors that the node can push out is the amount of segments. So the amount of sensors that it's been tested against for an IPI string, for example. So with GeoSense, we've just recently completed a test where we plugged 100 sensors into the node, and comfortably had room to spare. So the little asterisks on the side of all these numbers is the fact that we've run out of sensors to plug in. So this isn't even the top limit. This is just what we've been able to test with. The same with GeoCon, we've managed to plug 64 sensors in and run very comfortably. SysGeo and Osprey and soils as well. And we're just doing the final testing for soils, so we haven't got an exact battery life on there. So what it represents and what it shows is that, our digital interface node is extremely powerful. It's designed for you guys to put this into the field and have comfort that it's going to last throughout a project. As I said earlier, if you feel the need to put in mains power or even a solar panel with a step down, a DC step down, that's an option. And it's not limited to the number of segments. We can keep going. I'm sure. I'll just go through some applications now, and illustrate some types of projects that you and sectors that the digital interface node is particularly aimed at. That's not to say it's limited to those. It just gives you an idea of working scenarios that it applies to. So, I mean, the classic is obviously using it for an IPI, an in-place inclinometer. So the sensor partners that I showed on the previous section of GeoSense, GeoCon, Osprey, Soils, and SysGeo, it's plugging their sensors that are installed vertically within the ground, and they're looking for horizontal displacement, and anywhere from sort of 5-6 meter depth right down to 150 meters. Typically in a railway, you might put them in around 8 to 15 meters, where they're looking at a translational or rotational slide at depth and seeing how that behaves. It's very useful for when a slope or an earthwork has reached that critical stage, and you want to understand how things are happening and when they're happening and what rate they're happening at, to install sensors in and have it remotely configured so you're getting that information when you need it. You might also have, in this scenario, a digital interface node attached to a weather station. So you're also tracking things like precipitation levels and seeing if that's linked to any movement that you see within an in-place inclinometer. Again, very similar in terms of equipment involved, but in tailing dams, where you're looking at lateral movements, horizontal movement at depth. And so you'd potentially put IPIs in with piezometers, looking at lateral movement at throughout that tailing dam wall. And all these nodes would be talking wirelessly, as I say, back to the gateway, and the gateway sending it to our back end. providing 24/7 monitoring. And especially in the last sort of year, we've seen some fairly tragic occasions where tailing dams have burst, and monitoring them and understanding their behavior and whether they're starting to move and fail is becoming a very, very important part of ongoing asset management when it comes to tailing dams. And this is, again, I know these are very sort of in-place inclinometer heavy, but this is a project I was involved with many moons ago, Crossrail, where building the box station, lots of I think it was shape arrays in this case were installed within the walls, looking at the change of shape of the diaphragm walls as you excavate it down, understanding how the load was being transferred from the ground onto the walls and back onto the props when they put the propping levels on. So the monitoring here and the application of installing IPIs or shape arrays in this case, which connected wirelessly through a digital interface node, for example, was allowing the progress of the construction to continue in a safe manner, and for the engineers to understand how the load was progressing and where it was moving to and transferring, so they could carry on safely. Again, another project sort of ongoing at the C2, C3 section of HS2, where there were lots of IPIXs and piezometers and IPIs put in along the green tunnel section, to understand as they excavated down and put the prefab tunnels at the base of it, how those embankments were behaving, what impact they were having on the surrounding area in terms of groundwater, but also in terms of any settlement and heave of the extant summit part, and then rotation of the slope itself laterally. So again, another example of where getting access to these areas is, as you can see from some of those photos, is going to be pretty ropey, literally needing rope access. So having a node sat at the top of there, communicating its data away, meaning that once it's installed, you don't have to repeatedly go back and sample and put people in danger, but also get 24/7 coverage of how an asset's behaving. It's another example of where it might be useful is in hydrostatic leveling cells. Again, the ability of plugging in multiple sensors into one wireless node that then can communicate is a really important tool, especially when looking for changes in settlement of a building, such as this case. Hydrostatic leveling cells are a very tried and tested method of understanding how one sensor moves vertically in relation to the other, and instead of having to put to either take manual readings or wirelessly put a sensor on every single one, if you use a hydrostatic leveling solution that has a digital output, you can plug them into one wireless node that then communicates this information back to our gateway and back to our backend, and you can receive that information 24/7. And then finally, just on the application front, once again, I've talked about it quite regularly, but the weather station, looking at how, in this case, when you've got weather stations on cranes, looking at wind speed and rainfall, especially in geotechnical applications, is a really useful precursor to understanding how what might then create a vulnerable position for either a crane in this case or a slope, or how you might be at an at-risk point as the saturation levels come, and so again, it allows Senceive to add these types of sensors to our portfolio and offer a more complete solution to our client base. So I'm just going to touch finally, before we sort of summarize and wrap up, how InfraGuard. So some of you will have come across our intelligent monitoring system that's called InfraGuard. InfraGuard is a vital part of what we do, and we always try and to add value to methods and applications. And InfraGuard is a key aspect and a key product for us. It allows us to make sensors more intelligent by changing how they sample, reacting to different movements that they see. And so everything that we bring out, whether it's a sensor ourselves or whether it's a node that interfaces with a tried and tested sensor, we want to add a layer of intelligence on top, so it brings an extra value to the client. And so the sort of three features of InfraGuard that are very key to this product. One of them is network triggering. So if a sensor, so if you've got an IPI or a weather station that detects a level of change and breaches a threshold that you've set. So for example, in a weather station, if you say once it goes up to certain millimeters per hour of rain, I want it to trigger all the sensors that are in its network, so that the digital node will talk to any other sensors that's in within its network, which might be a piezometer, it might be an inclinometer, it might be a set of tilt meters, and request, or it might be a camera, and request them to take a sample. And it's a really useful tool because it means that you're not getting a reading in its isolation. You get a reading from all of the equipment that you've still installed on site, and means that you're getting a complete picture of what's going on. You're not seeing an alert go through for, say, an IPI and then having to wait 20 minutes or an hour to see what the corresponding tilt meter said or what the piezometer said. It will trigger everything within its network to take a sample. Responsive alarms. You know, one of the most important parts of Senceive's offering is making our equipment easy to install, quick to install, and completely autonomous. And to make it autonomous, we supply our gateways with a very 30-watt solar panel. But how we manage the information that comes into that gateway is equally as important as the battery and the solar panel. So what we do is we actually, the gateway will pick up data over a 15-minute period, and it will upload that data every 15 minutes. And it will wake up at that point, turn its modem on, and report its data, and go back to sleep afterwards, just collecting information from the sensors that are sat within its network. When we apply InfraGuard to our FlatMesh system, it means that when an alarm is received by the gateway, it will escalate that alarm regardless of whether it's due to or not. And that effectively what that means is that you're not the latency from a movement or a change being detected on site and the relevant person being alerted is minimized. It's kept as short as possible. So it's a very, very useful tool to apply. And then the third one, and probably the most useful, is dynamic sampling. So when movement is detected, so for example, in an IPI, you might say, if one of the sensors experiences a 10 mil movement, and at that point we're sampling every hour or every half an hour, the InfraGuard will make decisions through guidance from the installer of what to do next. So if it's moved 10 mil, it might say, well, actually, let's go to 15-minute sampling. If it moves to 20 mil, it might say, let's go down to 5. So especially in the case of an IPI where you might get a very slow moving failure, which starts to speed up, you should start being able to see it move through its alarms and getting those alerts as they come through, because the sampling is actually speeding up with that movement. So you're not, again, waiting every half an hour and then realizing the half an hour later, actually, it's completely failed and it's too late to shut the highway or the train, sorry, it's already on the track and we've missed it. The idea is that as it if it does start to move, you're starting to get more and more samples from the node, which is sampling the sensors. So you get more and more information. The alarms are going straight through as soon as the gateway receives them, and the system is triggering everything else in its networks. If you've got a camera and a weather station, you're constantly getting updated with what's going on site as and when it happens, and not having to wait for that to occur. Oh, sorry, I just went through. So yeah, just I think 330 on the nose. So just to summarize some of the key points of the product and some of the key takeaways that I sort of want people to go away with. The node is obviously the first of a new generation, which allows clients to really manage and control the maintenance of the system. But it also has, this particular one has a very high power output. It's a very efficient battery management. So it really lends itself to putting these in place and running for a long time without the need to keep returning to site. But it also means that if you do need to and you want to change batteries, you can do that fairly readily without having to bring lots of tools with you. We also have the DC input option, which might not sound particularly exciting, but the relationship between the DC and the battery is fluid, so it means that it will take whatever the best power source it has. So if you've got a DC that, unfortunately, in the world of monitoring, people do constantly pull out powers to plug their buzzsaw in or other things, it will automatically flick onto the batteries that are on the node, so you don't have to go and physically tell it to. You won't ever lose any information. The product itself is unique in the fact that it's available on both our mesh and our GeoWAN platform, so you can use it with all of the capabilities and all of the strengths that mesh holds, as well as using it on GeoWAN for longer range. We have an extremely wide range of outputs, of sensor outputs of the digital format that you can interface with, whether it's 232, 485, STI12 or CAN. And obviously one of the big selling points for us is InfraGuard. Now, InfraGuard doesn't apply to GeoWAN because it uses the thick bandwidth of mesh, but when coupled with mesh, it offers some intelligence and allows you to really control and manage how your sensor that's plugged into the digital interface node behaves, and gives you confidence that you're going to receive and get the information you need when you need to. Okay, excellent. I will see if there are any questions in. Okay, let me just, apologies while I just work out how to see the questions. Okay, there's one from Biana. So the question is, the battery life shown, is that for the normal battery? Yeah, so the batteries that we achieve, the battery life we achieve is with our own batteries. You can't plug in just any battery off the shelf or from the shop. So you have to buy we've had some bespoke design batteries, which may appear a bit difficult, and I apologize if people see it that way, but it's done on purpose because off-the-shelf batteries have limitation, which means you can't achieve the battery life that you want to, or we wanted to. So we've got some specially designed batteries. As I said, we're not precious about whether you buy them from us or bulk buy them from us, or you go and we give you the details of our supplier and you go buy them direct. That's not, the aim is not to make money off batteries. The aim is to maximize the output of the node. And so we have some specially designed batteries for that. And that was it on the question front. Oh, yeah, so a follow-up question, I think, from Biana again. So yeah, for the low temperature battery, I probably didn't explain that very well. If you're going to put the DIN in a low temperature battery where it regularly gets below -10, it will we have a specific low temperature battery which will achieve exactly the same output as the normal battery. The 50% reduction was if you put the normal battery in a low temperature environment, if that makes sense. So if you put the normal battery that comes with the node, and you go and stick it where it regularly goes under -10, you probably will see about 50% reduction in the battery life. So that's why we've got in that occasion, it's important to understand where it's going, and we have a specifically designed battery to put in that environment, which means you get the same output as a normal one, and so that you won't lose anything on the battery life. Another question: how many sensors can be attached to a digital interface node? So I'm going to sound like a politician here, but it does depend on the type of sensor and the sensor manufacturer. So every sensor has a different way of working, has a different power draw, and so we can only talk about it in specifics. So specifically, if we look at the GeoSense IPI, only last week we tested against 100 sensors that were plugged into one sensor, one node, sorry, and even that wasn't reaching its full capacity of one of the digital interface node. We still had room to spare. In fact, there was a 100-meter leading cable that was we're losing a bit of power down. So GeoSense have a particularly efficient low sensor, so that can't be just replicated across everything. And so what we've tried to do, especially in our product data sheet, is be specific to the sensor manufacturer. So you'll see on there that we've got a maximum number of sensors tested against. So it's not theoretical; it's tested against for every manufacturer that is currently aligned with our product. And as I said, we can make assessments or theoretical guesses on the maximum, but a lot of those is down to how many sensors we can actually physically test with, rather than, when we go to some of our manufacturers' warehouses, if they haven't got that, if they haven't got 150 stock, we can't test with 150. So that's where I put that little asterisk next to them. Is what we've tested against. We've been more than comfortably able to talk regularly, and it's not just about getting power down to the last sensor. It's about doing it over a period of time to make sure that we're not missing sensors and we're not missing readings. So it depends on the manufacturer, but if you look on our sort of data sheet, you'll see that the minimum for any of the IPI suppliers we've currently integrated with is 50, and we've comfortably gone up to 100 with one of them, and lots of room to spare on some of the others. Okay, another question: how many DINs can you connect to a gateway? Again, sound like a politician here, but it does depend on how many sensors you've got and on a digital interface node, and how quickly you're sampling on that node. So we generally say, as a rule of thumb, if you've got 25 to 30 FlatMesh digital interface nodes on a gateway with an average of 30 sensors plugged into it, that will be comfortable. And if you want to increase that number, we just want to look at the type of sensor that you're plugging in, the amount sampling, and we'll be able to give people an answer on that. In terms of GeoWAN, so using LoRa network, it's a lot more, because the GeoWAN, the gateway itself generally requires mains power. You can run it off solar panel, but it generally requires mains power. So you're a little less limited by the power effort that goes into it. Just looking through. Okay, so next question. Thank you. Is the intention to replace the current nodes with the new digital nodes? So no, we're not. we're not looking to, well, there's two parts to this, if I understand the question correctly. We're not, the digital interface node doesn't replace millivolt per volt potentiometric vibrating wire. Apologies, I probably didn't make it clear, but there is a time and a place for most of these outputs, and then they all have a specific application they really lend themselves to. Equally, so does digital. So we're not going to, certainly not going to reduce our portfolio by taking vibrating wire and potentiometric and PT100 off the table at all. No, that it's just adding to it, so we can make sure that we can interface with more outputs. But we will, in the course of the future, be going through those products and revamping them with the design that we have here, making them easier for people to maintain, making them easier for people to configure the different sensors with, and that's in our roadmap for the future. Just see next question. I've got a question here, 1 port or 2 ports. So there's only 1 port, so you can only plug 1 string in, so 1 bus system in. There are 2 ports, one's for power, one's for the sensor. So you can't plug 2 different sensor strings in. So for example, if you had an IPI and an extensometer individually, you can't plug them both into the same digital interface node. You can only plug 1 string in. But luckily on the market, there is in that particular case, there is an IPIX available, so you can get that would work perfectly, because it comes in 1 output and plugs into 1 port. Another, well, sort of statement here, we want to sense loads. So in terms of loading, if you have a load cell that has a digital output, that is something we can integrate with and work on the firmware to do that. And I recommend you sort of highlight that to us, a specific type and a specific sensor. We can go away and look at it and how we can plug that into our digital interface node. So another question here, how does the wireless transmission perform in a tunnel, e.g. in straight or curved tunnels? So this is probably a bit generalized, more away from the digital interface node. The digital interface node behaves in exactly the same way as any of our other nodes on the net, on our wireless and GeoWAN platforms. We've recently done, so if we talk about the 2 platforms individually, tunnels are actually quite useful for us because they act as a conduit, bouncing signal along, which means we can generally get longer transmission lines than say out in the open. Typically a GeoWAN product, we've tested it up to 2 or 3 kilometers into a tunnel from node to gateway. We've recently done a test with our GeoWAN track bed, where we put nodes up to 1 kilometer away. So obviously the node is on the ground, so it's in its worst environment. And we put nodes on the ground, and it's traveled through a tunnel out the other end to 1 kilometer away quite comfortably. But that's GeoWAN. That's one of its values. Using a LoRa-based network, FlatMesh, depends where you put it within the tunnel. If you put it on the ground, the tunnel acts almost irrelevantly. If it's on the ground, the mesh still has the same values as it would whether it was outside. And generally we get 8 to 9 meters is the longest you can put 2 FlatMesh nodes away from each other. Not that we generally don't recommend that, because then you can't allow any hops. If one node falls foul, then you could lose some of your sensors. Once you put the nodes at knee height, we're up to sort of 50 meters. Once you put it overhead height, 150 to 200 meters. But there's a lot of variables in that, so it's not you know, you might see some things on stat sheets and PDSs, but ultimately it depends on the tunnel, depends on the furniture. As the question asks, it depends on the curvature of the tunnel. Concrete tunnels generally act a little bit better than, say, a brick line tunnel with lots of water inside it, or ingress. So it's again, I'm sorry if I coming across too diplomatic, but it sort of is bespoke to the environment that you're putting it in. But there's some general rule of thumbs that you can use. Okay, next question. Ooh, sorry. Is it durable as your other sensors in terms of waterproofing and operating temperature range? So yes, it's IP 6768. So it's the same as all of our other sensors, and the temperature range is minus 20 up to plus 80 degrees, which is the same as all of our other nodes. As I said, the only slight variable is the batteries. We like to we want to put you know, we've learned through the years that putting different types of batteries to different environments will get you a better efficiency. So that's the only slight variance on that. Can the sensors node be reinstalled with ease? Yes, absolutely. That's again part of our remit is always to make things as easy as possible. So the IPI string, and that's I keep talking about IPIs. Obviously, there's lots of different sensors that you can plug in, but at the moment, IPIs are the main sensor we've launched with. But configuring those to the node is a very straightforward process. You'll see in the next coming days, we're launching our data management platform called Senceive IO, which allows you to set up all of your nodes and configure your nodes yourselves. And so in that, when you're configuring a digital interface node, there is a very simple drop-down menu where you pick the manufacturer that you want to integrate with, you pick the number of sensors that are going to be attached to it, and you press configure, and that is as simple as it gets. So the node will then know what it's expecting and know what it's talking to, and then you can configure that node to the gateway of your choosing. If you want to go and add that to an existing site through Senceive IO, if the gateway's on there, you can then say talk to that gateway, and off we go. So yeah, very simple. So can the digital node be powered by solar for both mesh and LoRa and GeoWAN? So yes, the digital node is, and I probably haven't explained this very well, so apologies. So the digital node it acts like any of our other nodes. So how it's powered is irrelevant to what network it's on. The gateway is slightly different. So the gateway for GeoWAN acts on the principle that it's always looking for messages in LoRa. So it's always, whether it's our sensors or anyone's sensors, it's always listening and it's picking up all information, and then we're siphoning out what actual nodes are ours and what are talking to what our network is. Whereas FlatMesh knows exactly what's in its network, so it's listening for the exact nodes that are in its network, and it's taking that information in and passing it on. So the fact that one's always on and one's on when we tell it to be on means that we can control the power in different ways at the gateway level. At the node level, that doesn't matter. It's sending its information regardless. So whether it's a FlatMesh node or a GeoWAN node, you have different options of how to power it. You can use the batteries, as I said. You can use a mains power supply, or you can look at a solar panel with a DC converter so that you're running it off that. It transfers across different communication networks, whether it's LoRa or FlatMesh, but the energy and the power is exactly the same. So we don't have those battery lives that we put there. It's not different for FlatMesh or GeoWAN. It's the same. So the answer to the question, they can be both if powered by solar panel, if that's the if that's the requirement. Next question, what is the warranty period and is there a different warranty for the device versus the battery set? So no, at the moment there isn't a different warranty if you just buy the device versus the battery set. The node is what we offer under warranty, and at the moment it comes under our standard year-long warranty, but there are plans to extend that. Next question, do the IPI manufacturers have the DIN plugs? So it's plug and play with on-site with no wiring needed? Yes, so it's a very, very good question. About how the digital interface is transported and sold. So the digital interface node will be sent out as a node and with a connector. If you have the IPI yourself, and it's recommended that you do the wiring before you go out on site, so you don't do the wiring out on site. I mean, some people still do, but that's probably against our best practice. But we also send the connectors to the manufacturers as well. So if you were to go and order an IPI directly from them and said, I'm going to interface with the Senceive digital interface node, they can do the wiring for you. So it's as simple as you can make it, and when it arrives, you simply just plug it in. What time are we on? Got time for a few more. I think that was the last one. Just checking, there's no more that I've missed. Nope, looks like I've got all of them. Apologies if I haven't. My email address is over the invite, so you can get in contact with me directly. Brilliant. Thanks for taking the time out to listen to us, and also putting through a lot of questions. It shows a good engagement, which is great. Thank you very much. Thanks for your time.